Okay. For the people just joining us, we are. I asked people to try this problem on their own, so take a minute to try it on your own. But here, and then come back in just a minute for the answers. Here we go. Remember, type 1 is rejecting incorrectly. Type 2 is failing to reject incorrectly. So a type 1 error, rejecting incorrectly. So think about what rejecting our null hypothesis would mean in this setting. Rejecting would lead us to conclude the alternative. So we would conclude that our proportion is less than 0.63 when it actually isn't. And then our type 2 error would be failing to reject incorrectly. So in that case, it would be we wouldn't conclude that that proportion has been reduced when it actually had. And then there's a sentence there about some of the consequences. But that's just a reminder of our type 1 error and type 2 error.
Wait, what's type 2?
Type 2 would be failing to reject incorrectly. So type 2 is failing to reject when we were supposed to reject. We're supposed to include the alternative, but our sample that we get leads us to fail to reject our null hypothesis, when in reality, our parameter has actually changed. So failing to reject when we were supposed to reject.
So rejecting incorrectly is literally just picking the alternative hypothesis and the alternative hypothesis being wrong.
Correct.
Failure
Yes.
to reject incorrectly is saying
Is
that the
not concluding the alternative.
Is saying that the alternative is wrong when in reality
it's right. Yes.
Okay.
That's type 1 and type 2.
My turn. Like me terms.
Yes.
Video of you saying that
Yeah.
I understand.
That's good. So, to say that, yeah. So another way, yeah. So again, another way to say that is that type 1 is not concluding the alternative, because that's what rejecting incorrectly. Type 1 would be saying that you're concluding the alternative when the alternative is wrong, when the alternative is actually not true. Because that's what rejecting would lead you to do. It would lead you to conclude the alternative when the alternative is not right. Type 2 would be failing to reject incorrectly. So that means that we don't conclude the alternative when the alternative is actually true. And so these are all about putting this in the context of this question. Anything else on type 1 and type 2 error before I move on to apply it to talking about power?
I just have a question.
Yes.
At some point in this review for the AP test, are we going to go over probability?
Yes.
Okay.
Definitely. We have 2 days set aside for it. All right. So that is our type 1 error and type 2 error. Now I want to focus in, we're going to focus in today, first off, I want to start by asking this question. Maybe I won't ask this question because the smartboard won't cooperate. There. Nope, not yet. Okay, probability type 1 error. Think about what the probability of a type 1 error is. In other words, what is the probability that we have our null hypothesis, it's true, it has this distribution, but we happen to be unlucky and get a sample that leads us to reject it. So the probability of rejecting the null hypothesis when it's actually true. Wait, think on that for a minute. Well, I get the smartboard working again. So we're gonna take my example of my masterful free throw shooting again.
I was literally thinking that in my head.
Null hypothesis is that I'm claiming that I'm an 80% free throw shooter. The alternative, should you dare to suggest it, is that I'm not quite that good. All right. So there's your null and alternative. So what the null hypothesis is saying is that p equals 0.8, and then I could get a distribution of what that would look like. It would, be approximately normal as long as n times p and n times 1 minus p are both at least 10, et cetera, et cetera. So there is a sliver of these that if the null hypothesis is true, if I really am an 80% free throw shooter, sometimes, we talked about this, sometimes by bad luck, I'm just going to have an off day, and my free throw percentage is going to be lower, and it's going to be in this region that would lead me to reject. Okay? And this is my reject region. And the proportion of the time that I do that depends on my threshold for rejecting. In other words, this probability for a type 1 error is my alpha level. That is what the alpha level is. Because remember, if my p-value is less than alpha, then we reject. That means we are taking that probability, that is the probability that the null hypothesis is true, but I just had a bad luck of distributions. So let's say my alpha level is 0.05, then that means I'm willing to accept that 5% of the time I would get a free throw percentage that low if the null hypothesis was true. But since p-value is less than that, since it is in this region and the p-value is less than that, I would reject and be making a type 1 error. So usually we choose 0.05 because it's a good balance between these two. But if we had a situation where we really didn't want to make a type 1 error, we could lower our alpha level, and that could help us not make a type 1 error as much. Okay, so that's thing number 1.
Will we ever get in trouble on the AP test? Or not get in trouble, but like not get it right on the AP test if we decide to keep it at 0.05 if they determine that it's like not, I don't know how I want to word this. They wanted us to make it 0.01 because it was important that we didn't have a huge like error margin.
If they wanted you to use an alpha level, they will tell you what alpha level to use.
Okay.
Otherwise, use 0.05.
Gotcha.
That's what we've said. Anyway, so that's our probability of type 1 error, alpha. And so you might see the probability of a type 2 error called beta. So type 1 is alpha, type 2 is beta. Now, let's approach this in the other way. Let's say we reject the null hypothesis, not committing an error this time, not an error this time, because the null hypothesis is actually should be rejected. So my alternative is actually true this time. So let's suppose that I have my claim again of I am an 80% free throw shooter, and then so you decide to test me by having me shoot some free throws, and while I'm doing that, you receive word from on high. He's actually a 50%. He's not as good as he says he is. Okay, and you receive this little whisper in your ear that that's the actual parameter. That the parameter is actually 50%. Now, what does your actual distribution look like? Instead of being centered at 0.8, like I'm saying it is, my actual distribution is over at is centered over at 0.5, all the way over here. And that's what the actual distribution, I put it in green because it's the correct distribution. My rejection threshold is still over here. Anything less than this value, and I'm going to reject. And so out of the actual distribution of free throws that I'm actually going to shoot, this is the amount of the time that you're going to catch me and reject the null hypothesis when you're supposed to. So the idea is you receive this knowledge of what the actual parameter is. So how often are you going to reject the null hypothesis? So in other words, it is how often you reject when you're supposed to. That is what power is. So power is, if the parameter is actually this thing, how often is the null hypothesis rejected? So again, it is under the assumption that my alternative is true. Under the assumption that the alternative is true. So that is my definition of power. Or more specifically, it is the probability of rejecting the null hypothesis for a given alternative hypothesis. Or for a given alternative parameter. And so we're gonna talk very briefly about what things influence the power of a test. One of them is that actual alternative parameter that goes in this blank. So let's say I'm lying about my free throw percentage. It's not actually an 80% free throw percentage. When are you more likely to catch me? If my free throw percentage were actually 70%, if it were actually 50%, or if it were actually 30%. Which one? The 30, right? And that's because I'm much less likely to get a series of free throws that are going to fool you if I'm actually at a 30% free throw percentage. Then the probability that I get the chances that I actually get a series of shots that fools you into thinking that my percentage is 80 is pretty low. I'd have to have a really lucky streak in that case. So in other words, my actual parameter that I receive from on high, the farther away it is from my null, like the more convincing the evidence it gives in the direction of the alternative, the higher the power of the test. So as an example, here is this multiple choice question. This is an example of how they might ask about power. There's my threshold for rejecting.
The way that this was difficult for me learning the null and alternative, but it's not as bad as I thought.
Good. That's part of why I saved it for later, is because if I had done this on where the book has it, which is like right after you learn about what null and alternative are.
Yeah, that's adding too much.
That's why usually I do it at the very end of the chapter on hypothesis testing. But I decided that I think that would have crammed it in right before spring break. I didn't want to do that. So we're doing it now. Okay. So let's say we have, let's take it being centered at 3. That is not centered at 3. Let's try that again. Closer. All right. So again, anything to the left of that blue line is where we're going to reject. In other words, the more power the test has means that it is going to let me detect that change in the mean more often. So if the mean is actually centered at 5, then I'm going to reject a lot less often than if, say, the mean is centered at 1. Look at how often I catch that the mean is actually less than 5. A lot more often. So our answer would be 1. Oh, I forgot I drew it on the next slide. Okay, one more. Yeah, null hypothesis, what we were assuming. Here's the actual distribution. Okay, one more thing. Well, a couple more things, but one more thing for this problem. The opposite of this distribution, where I reject when I'm supposed to. So here's the actual distribution, and I reject. The opposite of that is here's the actual distribution, and then I fail to reject. Uh-oh. Which error is that? There's the actual distribution, and I failed to reject. Type 2. So the opposite of the power is making a type 2 error. So that's why I said back at this slide that power is 1 minus the probability of a type 2 error. So another way to think about power and how it's going to affect power is, what is it going to do to a type 2 error? Because whatever it does to a type 2 error, it's going to do the opposite to it's going to do the opposite to power. So in other words, another way you can say that this answer is A is because as my actual distribution moves to the left, hey, the mean is actually 4, or the mean is actually 3. As this distribution moves to the left, I'm less likely to make a type 2 error and more likely to make that correct decision to reject. So type 2 error goes down, power goes up. And so here are these couple more things to know. Well, let's do this question. This one's a little bit tougher. Think about the way that made sense to you. Whichever way made sense to you to think about it.
So when you increase the power, you decrease the likelihood of getting a type 2 error?
Correct.
Oh, yay.
Yes. Yeah, if you're wanting to understand power, then today's for you. If the one thing you get out of today is that power is 1 minus type 2, then that's not too bad. You probably won't be in too bad a shape.
Well, already today I've gotten the type 1 and type 2. So I probably should have known that 3 chapters ago, but I'm just happy I'm getting to it now.
I forgot one of the choices I threw into this question. Yeah. You get more powerful.
Power. Shoot.
Working out and building.
Yeah. Increases your power.
Dude, we get to do a research project
A
and we.
flat, Mr. J. I was in A flat with you.
Oh yeah, you were.
Okay.
Oh, we don't have to do this. We just do like our decrease the answer.
Yeah.
Decreasing the alpha level.
I like how Meg decreased the probability by type 1.
Well, you were gone.
Decrease the
for a little
probability
bit,
type
too.
1 error, correct?
Wait, so the alpha level, is that synonymous with, not synonymous, but like linked with type 1?
Yes. Alpha levels linked with type 1. Okay. You should be between two choices, hopefully, which would be A and C. Yes?
Oh.
Okay, so we're narrowed down to A and C. All right. Here's the way to think about the incorrect answer. If I decrease the alpha level, am I going to reject more often or less often?
More often.
No, less often.
So if I'm using a 0.01 alpha level, if that's my threshold to reject instead of 0.05, if I'm using a 0.01, then that means that I'm going to reject less often. It's going to be harder to give me a p-value that will cause me to reject. So if I'm trying to catch rejecting, then decreasing the alpha level is going to bring power down because I reject less often, which means I catch the parameter changing less often.
So increasing the sample size because it gives more opportunities for you to mess up in your free.
Correct. That's where I was going. Is that, again, let's say my free throw percentage is 50%. Would you rather try and catch me out by making me shoot 10 free throws or making me shoot 10,000 free throws? Which one is going to be more likely to catch me shooting my actual free throw percentage of 50%? The 10,000. Or, in other words, here's my actual distribution. Right? The actual distribution is 50%. Increasing sample size will decrease spread. So getting a fluke set of free throws that lets me get away with saying that my free throw percentage is 80%, much less likely if I'm taking a higher sample because it decreases variability. So here are the big ones to know. Power goes up when sample size goes up. We just talked about that. Because you're more likely to catch me by giving me a larger sample. Alpha level goes up because we reject more often in that case, which means you're going to catch the change more often. Actual parameter is farther away from the null hypothesis. So that means if, I have a lower free throw percentage, then I'm less likely to be able to fool you into thinking that my free throw percentage is high up. Or probability type 2 error goes down. Because power is 1 minus probability of type 2 error. So if type 2 error goes down, then power goes up. They go in opposite directions. All right. Questions on that?
Can you leave it up for like 2 more seconds?
Yep. I'm just turning off the